So we're going to talk about the enthalpy of formation. So enthalpy of formation is defined as the enthalpy change in the process of doing the formation reaction. So the formation reaction refers to the process of forming 1 mole of a substance in its standard state from its constituent elements and their standard states. So the key points here is that 1, you only form 1 mole of a substance, and 2, that the substance has to be in its standard state, and it has to be formed from its elements and their standard states. So standard state refers to the standard state of a substance in its most stable form under 1 bar of pressure and 25 degrees Celsius. So 1 bar of pressure is about 1 atm, not quite, but fairly close. So under atmospheric pressure and about room temperature. So to give you an example, here we have the formation reaction for water. Notice this is only for 1 mole of water. So we have 1 mole of H2 plus half a mole of O2 gives us 1 mole of water here. So delta H for that reaction would be delta H for the formation of water. The standard enthalpy of a reaction is the energy associated with the reaction that takes place under standard conditions. So sometimes we also call that the standard heat of reaction. So you will see either of those terms, the standard enthalpy of reaction or the standard heat of a reaction. So there are tables for delta H of formation values for different substances in a table in your book, and they're usually located in an appendix at the end of your book. So the way that we calculate the standard heat of formation, or the enthalpy of reaction, either term applies, is that we take the delta H of formation for the products minus the delta H of formation for the reactants. So this looks like a lot of writing, a lot of letters here, but what this really is boiling down to is that you have to take the heat of formation for each compound times the number of moles of that compound, and it's always products minus reactants. So don't flip those. That's something that students sometimes do, and it's easy to get those two confused. It's always products minus reactants. So let's take a look at an example here. We want to use the values below to calculate an approximate enthalpy of reaction for the reaction that's shown here. Now one thing I want you to notice is the delta H of formation for oxygen is 0. That is the case for an element in its most stable state. So if you see a reaction where you're asked to calculate the delta H of formation, and you're not given delta H for one of the compounds, look and see if that compound is actually an element. If it's something like N2 or O2 or I2. If it's an element and it's in its most stable state at 25 degrees Celsius, then its delta H of formation is going to be 0. So let's go ahead and calculate the delta H of formation for this reaction. So we have CH4 and O2 as our reactants, and CO2 and H2O as our products. So delta H here is going to be equal to, remember we do products minus reactants. So there's only 1 mole of CO2, so I can take negative 393.5 kilojoules per mole and there are 2 moles of H2O, so I have to multiply the value for H2O times 2. So I have negative 285.8 kilojoules per mole. And then I'm going to subtract off the reactants. So I only have 1 mole of CH4. So minus negative 74.8 kilojoules per mole. Plus, there's 2 moles of O2, but it has a delta H of 0. So essentially, this cancels out, because 2 times 0 is 0. And if I add 0 to anything, that's just going to give me what I started with. So I'm going to take negative 393.5 plus 2 times negative 285.8 minus a negative 74.8. And when you do that, you should come up with negative 890.3 kilojoules. Okay, let's try one more example here. Calculate delta H in kilojoules for the synthesis of lime, which is calcium oxide, from limestone, which is calcium carbonate. And we're told that carbon dioxide gas is also a product. So we're not given the equation, but we can write it from what we're told here. We want to calculate delta H for the synthesis of lime from limestone. So limestone is calcium carbonate. So calcium carbonate would be CaCO3. And we get calcium oxide. And CO2 as our products. Cool. So, and it just so happens to work out that this is balanced, and you can go through and count up each of your elements on each side and double check that. So let's go ahead and calculate delta H for this reaction. So we have delta H is equal to, so our products are calcium oxide and carbon dioxide. So we have negative 635.1 kilojoules per mole. And I'm going to put this in parentheses just so that positive and negative signs don't run into each other. So negative 393.5 kilojoules per mole. And then the delta H of formation for calcium carbonate is 1206.9 kilojoules per mole. So if we take negative 635.1 plus a negative 393.5 and subtract a negative 1206.9, you should come up with 178.3 kilojoules per mole. Okay, so we're going to stop here, and I will see you in class, and we will get some more practice with this.